So we're given this rational function, and we're asked to find the domain, any vertical asymptotes, holes, x-intercepts, y-intercepts, and can't see it on here, but also the horizontal asymptotes. Basically everything about it. So let's talk about where everything comes from. So the domain comes from the denominator. I know this is probably difficult to read in the video. This is x squared minus 3x minus 4 on bottom, 5x squared minus x on top. The domain comes from the denominator. Specifically, we can't have zeros in the denominator. So x squared minus 3x minus 4 cannot be 0. And then you can solve this with the quadratic formula, graphing. In this case, we've got one that'll factor into x minus 4 times x plus 1. Can't be 0. And that leads us to get that x cannot be negative 1 or 4. And we usually like to put these in interval notation. So doing so, we just need to exclude these 2 points. So we're going to go from negative infinity to negative 1, negative 1 to 4, and then 4 to positive infinity. And there's our domain. The vertical asymptotes are any points we don't want to include in our domain that are not zeros of the numerator. So I'm actually going to come back to this one, to B and C, because they're related, and find if there's any x-intercepts. That's where we set the numerator equal to 0. Again, I know it's hard to read in the video. It's 5x squared minus x equals 0. So we will factor in x out there. We get x times 5 minus x equals 0. So we have 2 x-intercepts, x equals 0 and 5. Now here's where we would check. If you have any x-intercepts at the same value that you have excluded from your domain, that's when you have a hole. Since we don't have any overlap there, there are no holes, and both of these, x equals negative 1 and x equals 4, are equations of our vertical asymptotes. And all this can be confirmed from the graph. The y-intercept comes from putting 0 into our function. So f of 0, go back to the function here, you're going to get 0 minus 0 over negative 4. So 0 over negative 4, which is 0. So this thing goes through 0, 0. And then if there is a horizontal asymptote, we want to find it. So you look at your leading terms of the numerator and denominator. And basically, so we get 5x squared over x squared. So for large x, this thing approximately acts like this. Those cancel, gives us 5. That is our horizontal asymptote. So y equals 5.